methods that we can use for subtracting across zeros. The first one is that we can just do it the plain old way where we do a lot of borrowing. Let's say we have a problem like this. If we are trying to take 3 away from 0, we cannot, so we have to go next door to see if there is any tens that we can borrow. Fortunately, no one's home, so we need to go next door to the hundreds place. We bring this down by 100, so we're bringing 100 over into the tens place. We regroup that into 10 tens. Now we have 10 tens from that regrouped 100. Now we still don't yet have anything here in our ones place, so we're going to cross this out and bring it down to 9. And we're going to bring over 110 to our tens place, or to our ones place. Now we've got 10 ones in our ones place. Now subtraction gets a lot easier after all of that borrowing. 10 minus 3 is 7. 9 minus 7 is 2. 4 minus 3 is 1. Our answer is 127. Now let's look at our second option, which I like to call the subtract 1 method. So if we have our problem of 500 minus 373, I'm going to lower both of these by 1. There will be no difference in our answer. Our answer still will be 127. Now if we lower 500 by 1, we get 499. If we lower 373 by 1, we get 372. Now, you're going to see, or wait and see, if our answer is still the same. Should be, because if we're just lowering these both by 1, it's the same distance away as 500 minus 373. So now I go to solve, and you're going to notice that it's so much easier because I now have nice big numbers on the top of my problem, so there's no borrowing needed. 9 minus 2 is 7. 9 minus 7 is 2. 4 minus 3 is 1. Our answers are exactly the same as you can see here, 127. The reason why this works is because 499 minus 372 is the same distance away. It's 127 away from each other. Because we lowered this by 1 and we lowered this by 1, we are the same distance away from 500 minus 373. So even though we changed the problem, the answer is still the same, as long as we change it the same amount. One more thing to show is when we have a problem like this, where we have 70,038, and we're trying to subtract 42,689. This is where it gets a little bit more complicated because we have 9 minus 8. And we can't do that, and we have some zeros here. For this, I recommend that we do all of our borrowing so that we can keep going next door. What we're going to do is we are going to say we can't take 9 away from 8, so we go next door to the tens place. Knock, knock, knock. Is somebody there? Yes, 3's there. We lower 3 to 2, and we bring over 10 ones. Now we have 18 ones. 18 minus 9 is 9. Now we're in our tens column. We're trying to solve 2 minus 8. Unfortunately, we can't take 8 away from 2 because 2 is smaller than 8. We go next door, knock, knock, knock. Is anybody there? No one's there. We go into our thousands place, knock, knock, knock. Anybody there? No one's there. In our 10,000s place, we see 7. 7 will help us out. We'll lower it to 6. Now this is where it gets tricky. We bring 10 over into our thousands column, but we still need to bring it over into here. We lower 10 by 9, bring over 10. We're still not done. We need to bring some over, so we lower 10 to 9, and we bring 10 next door. Now we've got 12 tens because we're in our tens place. 12 minus 8 is 4. 9 minus 6 is 3. 9 minus 2 is 7. 6 minus 4 is 2. Now, when we have 2 zeros, it does get complicated. We can do all of our borrowing. All right. I hope that helps, and good luck.